Welcome to another episode of the Bay Area Scala Enthusiasts Meetup. Here we are at Oracle. It's a wonderful thing. Oh, did you see our nifty logo in the corner there? Peter Potts won the contest last month. That's a pretty good logo. I want to thank Michelle Kovac for making this happen. We have a kind of a little bit of a pattern where we've grown to about 1,130 odd people now, which is good. We're still number 2 in the world. New York is still ahead of us. They're at about 1,300. We are making the distance by half every month, which means we'll never catch them. We serve the whole Bay Area. We have 12 volunteers now, including myself. I have an announcement. I work for Micronautics Research. We've been slaving away for months and months on some course material specifically for Java programmers who are learning Scala. So all the material is really slanted to people who have the Java mindset, have the Java skills, and are trying to twist their brain around into some other way of thinking, piece at a time. So next month, sometime, maybe in about 30 days from now, if all goes well, we'll be offering early access to the material and our online delivery program. Our courses are actually available now, so we can do in-person training. What we're going to be offering is remote training. And so if you want to know more about that, go to scalacourses.com. I want to say thank you to our sponsors, to Oracle, for making this happen. When we first talked about having this event here, we thought, oh, how will we reach them? It turned out it wasn't so hard after all. And so I do really appreciate the opportunity to be standing here today. Well, of course, I spent far too much time making all this happen. Micronautics Research is one of the sponsors. And Message Bus is very solid and been doing a lot for this group. So I should say that they do cloud email and messaging, and they're also, of course, hiring. They're in Corte Madera, so you can imagine that Daniel and Ilana came a long way to be here tonight. If you know people in Marin, then you should send some of the jobs at messagebus.com. All right, Paul, are you ready?
Hello. I'm Paul Phillips. I'll tell you up front that I'm not a big stand here and talk about my slides guy. This doesn't look like such a big room that we can't be participatory, so if you're dying to ask me something, please feel free. I have been working on the Scala compiler and the distribution for more time than I care to even imagine. Probably, I don't know, lifetimes, like 5 years of very little but. So there's a lot of incidental knowledge in my head, and maybe just enough useful stuff has been distilled out of that you can learn something on Valentine's Day. It is Valentine's Day, and I am married. But here I am. So the least that I can do is mention my wife and my daughters, who I will be giving a post-Valentine's Day. So they asked me to talk about the JVM, things happening on the JVM, how they impact Scala, what we could use in Scala, this sort of thing. There's a lot of well-covered ground, especially closures. Every time I go to anything remotely like this, everybody wants to talk about closures all day. And legitimately, because this whole idea of moving the code to where you want and separating the iteration and the actual thing being iterated, these are big, important things with grand problems, and I don't want to talk about them because A, I'm not the most qualified, and B, you've heard it or you will hear it. So you can read Cliff Click, who knows 1,000 times what I do about this and other things. There's a little Earl at the bottom there. There will be other Earls sprinkled around if you're dying to follow up on any of this. I have a unique perspective on some of the things that the JVM makes annoying, just from my position deep in the sewers of the Scala implementation. So I figure it's better for me to talk about that stuff. Maybe somebody will be inspired to help. Yes?
Get a lot of URLs here. Are you going to make the slides available?
Of course. Oh, and that reminds me that I should probably just take a moment here and start the recordy thing. I'm not, I don't habitually do that sort of thing, and so, Well, I remembered, and I'll have to go back and fake the beginning. But, all right,
No worries.
record.
If you have a question, just raise your arm. I'll come running with the mic.
All right. Ta-da. Okay. So, yes, you do not need to jot these down with pen and paper. Of course, you could probably remember those, or at least you can remember the beginning, because the common substring algorithm will get you that that's John Rose, and lots of good ideas that John Rose has had over the last few years. I will briefly mention these because all of them are important, but because I know how it goes, I may as well talk about a couple things in a little bit of depth rather than 10 things in no depth. Name mangling, there's been this huge renaissance of all these languages on the JVM. Most of them have naming conventions that are not consonant with Java's naming conventions. Everybody invents their own mangling, and then it starts getting worse from there because there's an enormous number of hard-coded assumptions floating around in the universe, both in terms of software that interoperates with Java and Java itself. And if you violate those hard-coded, undocumented expectations about exactly how the characters line out, especially that $, which is, is like the god of reflection. If that $sign appears in the wrong place, everything's going to go. It's really primitive to operate this way. We know how to do things much better than this, but it can't really happen. Like, nobody can just come out and say, hey, look, I'm doing it this way, it's better. It's one of the few places where we really need Oracle to say, like, let's name mangle like this, and then everybody will do it, and then it'll be done. The 64-bit call boundary, by which I mean you can return a long from a method, and beyond that, you're going into the boxes. And when I talk about boxing, so I'm looking at the audience, and I have this sort of broad sweep of sort of familiarity with the material. So it's a little tricky for me to hit the sweet spot of having any idea what I'm talking about and being bored to tears. I'm probably going to lose both ends of that. So I will just briefly define a couple things, and if I'm telling you stuff you already know, please forgive me. But when I talk about boxing, we have much of the performance on the JVM hinges on not putting your ints into boxes and taking them back out all the time. That applies to all the other primitives too, but ints are really the big one because we just do a lot of stuff with ints, and the smaller things than ints we make bigger than the JVM makes them int size anyway. So we spend just a ridiculous amount of effort on trying to put all the plumbing together so that when time comes to add 5 and 7, we can just add 5 and 7 rather than saying, let's get out an object here, put a 5 on the heap, put a 7 on the heap, go tell somebody else where they are on the heap, have that guy come to the heap, get them back out, get the 5 out, get the 7 out, and add them. It's all day long we do this. And in fact, in broad strokes, we're terrible failures at it. If you actually count the amount of boxing going on in a language like Scala, or any language where you're not spending all your time being very sure to only work with primitives, there's an enormous amount of boxing because if you want to write appealing code, that is work at a high level of abstraction, you're just sunk. It's just too hard. It's a solvable problem, but it's a big, difficult problem. So boxing is one of those sort of factor of 10 things. The difference between endemic boxing and avoiding all the boxing is about a factor of 10 in performance. I mean, that's very hand wavy. We can move it around depending on the circumstances, but that's the kind of value that's at stake. Even so, I'm not really going to talk about boxing. Value classes. So we have this neat new thing in Scala where whole allocations just vanish. This is actually some of the same sort of thing. We can create classes in Scala now called value classes, and we can perform operations on those things. And if the implementation can figure out that we're working with value classes, which are based on a single underlying value, let's say ints. So let's say we're bringing some identity to an int. We don't want every 7 to be the same 7. we want something like a meter. That's kind of like our canonical example value class. I want 7 meters to be 7 meters and not to be like just any 7, it's 7 meters. And so I want to write a whole bunch of meter-oriented code, but I don't want to be making these meter boxes all the time and putting my 7s in the meter boxes and getting them back out. I just want that code to be used on ints directly. And that's basically what you get now, which is really nice. But of course, once you get a little taste of that sort of thing, then it's never enough. And you want to do you have lots of things. You want to have multi-parameter value classes. You want to be able to write lots and lots and lots of code and have just magic happen under the hood so that you get that big boost in speed. And having seen the complexity of what we've done so far, I'm more than happy to leave it to Oracle to do multi-parameter value classes. I think that's definitely better than us. And let's see, the fourth thing I'm largely going to skip here. Oh, so this is, of people who follow this sort of thing, with any degree of obsession, I think 3 of those URLs are very well known, and one of them is a little more obscure, the last one, larval objects. But it's quite interesting because it's a perfect fit for one of our problems, which is lazy vals. So a lazy val is the Scala compiler, essentially, you declare a lazy val, and that means it's only going to be evaluated once. It's going to be the same value for its entire lifetime, but when it's going to be evaluated is unknown, first use. But the problem is we pay a big price for that convenience because it has to be thread safe. And so even if you know it's going to be evaluated quite soon and you're not worried about avoiding the cost of the computation, you still have to pay on every access until the end of time because it has to be volatile so that it is thread safe. It's because you never know. So if we had the opportunity to do what's suggested in larval objects, which is to say you have a period of time during which you can mess with something more and then you can publish it for real, then we would have the same opportunity with lazy vals and we could do the same thing. And this would be very beneficial because people use lazy vals in large part because of initialization order tricky issues. We have like 300 lazy vals in one class in the compiler. It's pretty hairy. No, we could never unroll that and say, okay, it's going to go in this order and set it up and keep it in that order. We have them as lazy vals because we depend on the compiler and on the natural order of things unrolling to determine the initialization order. But we don't need them to be synchronized beyond that, but we do need them to be synchronized right now because we lack that sort of capability. So,
extensively using lazy vals would hurt your performance? Is that what you're implying by saying that it's because they have to be volatile?
yes, making something volatile is definitely like a little tax on everything for the rest of your life. And when you add a lot of them, and then there are other issues as well, there's also bottlenecking up front because there's no mechanism for controlling where the lock is. So when you put 300 lazy vals in the same class, and they're actually all contending for that lock. So this is a problem too. Now I think we're going to open that mechanism up probably via macros so that you can say something about how you want lazy vals to actually be desugared. So if you really need to use different locks, then you can. But we're really dependent on the Java memory model for exactly what we can get away with in terms of what happens when. And so something that allowed for, the key thing in larval objects is that because right now you can do a lot as long as you're within the constructor of a class within the Java memory model, but there's no mechanism once the constructor has left to say that this is not yet published. But such a mechanism could be devised, which is what he proposes. Yes?
Getting back to volatile, it's my understanding that when the compiler or spews out whatever it spews out when it finds something marked volatile, that it causes the hardware caches, L1, L2, L3, to all get flushed, and it has to pull everything in again, taking hundreds of memory cycles. Is there can the compilers cope with that? Do they pay that tax every time, or they somehow?
Well, a volatile write has that kind of cost. Okay. But what we're actually looking at here are a lot of volatile reads. And a volatile read under the right conditions is actually relatively inexpensive, but it's still more expensive than a non-volatile read. Enough so that it's highly desirable to avoid it if you can, but it's what you're thinking of, like the massive like cache flushing, like that, you don't get that unless you're using volatile writes. And because in the lazy vals, we're only writing to it once. It's all the rest of our lives that we're reading it. So we have like 1 million reads and 1 write. But we'd really, it's like we could have 1 million non-volatile reads if we could just, get past that initial race condition. All right, so here's a bunch of things. These are all kind of fascinating in their way. I could stand here talking all day about the various encodings, because we have to take each of these sort of interesting things at the source language level, and I guess all of you know Scala to some degree or another, and turn it into something at the bytecode level, and with various degrees of wisdom, I think. Some of these encodings are, well, I guess you'll see, because I'm one of these guys that takes more pleasure in showing you like the worst parts of what we do than the best parts. So you'll see some, and you'll see. Let's see what's next. Oh, yes. And those are the easy ones. Then we are constantly plagued by some of these like little decisions that probably seemed like a good idea at the time in 2003 or thereabouts, like arrays being covariant, or having like the fact that you have to do like doubles and longs, you got to do them in like a pair of opcodes instead of a single one, and so it's no longer atomic, and just the fact that arrays are handled specially everywhere, and so we've got to handle them especially everywhere. These are just like these orthogonality poison pills. There's just nothing you can do without sweating the interactions with these things. And then, of course, Java also has its own set of things that always interacts with everything. What is it? The canonical thing, serialization. Like there's nothing that can ever happen on the JVM without interacting badly with serialization. And they're really going for the force multiplier now in Java 8, right? Because with lambdas, like I don't even care to imagine the matrix and then how that matrix remultiplies with our matrix. Somehow stuff keeps working though. I don't know. Bridges. Well, I've got some examples of the madness of bridges. And yeah, erasure is another one of those things where it'd be nice to go back and like reconsider whether we really just want to do erasure for erasure's sake. But access is my true haunt, because I never hear anybody talking about access as a problem. Well, they don't have to implement Scala as access, for one thing, I presume. And it's everywhere, and you step back and you look at all this pain we suffer, and you have to ask, why? Is it worth it? What is it really that we get out of access? There's the thousands of man hours or years that we could recapture by going back in time and just saying, there's public and private, something like that. Anything ridiculously simple, and life would be so much nicer. Because it's so hairy. The JVM is very helpful in trying to enforce whatever it is that's written in the bytecode. So if bytecode says protected or the bytecode says package protected, it's got all of 4 levels of granularity, then it's going to do its best to ruin your day by actually enforcing that when the time comes. Meanwhile, we've got 74 and a half variations on this, all of which we have to encode in an impossible situation because we're trying to implement all these features that don't exist, and the only way to do it involves circumventing the access restrictions, pretending that they're not there, and making other guys go around those. All of it is like, why are we self-imposing all this pain just so that we can circumvent it? And I don't have a good answer to that, but I will give you some examples of how this plays out. And the funny thing is Java should know better, because it's not like they don't have the same problem. When inner classes were devised, which I guess is Java 5, and they didn't want to break anything, right? Like we can go back to basically Java 4 is the last time anybody wanted to, don't break it, don't break it. You got to make everything work with everything the way it is. So it's like, okay, we'll come up with this really complicated encoding, and we'll, navigate the way things are, and who's going to know? So inner classes are implemented as regular classes that have a little secret field that holds the thing that's outside of them. And of course, that means that they need to be able to get at the private things of the thing around them, because that's how it's scoped. You've declared a class, and here's a private method. Here's an inner class, which wants to get at the private method, and it's supposed to, but it can't, because it's not really an inner class. That's fiction. So they have to make an accessor. They make a secretly named accessor, and they put it over here and say, don't look at this. It's a secret accessor. Now multiply that by like 1,000, and then you have what we have to do. Because they've got to do that to maintain 4 levels of access. And they got to design it for themselves. That's Java, not Scala. And that's just basically my simplest example of where this would arise. That looks like a nice, straightforward thing, but it isn't. And that's what you get. Access $000. It's a nice and off-putting name. And you see that's a static method on J, which takes a J and invokes F. So it's by virtue of being on J, it can access the private method in J. So now there's a public method that you can call, which will take a J and call that private method. All right, problem solved, right? We've found the shim, and we've put it here. And like I hope somebody was thinking like, I wonder where this leads 10 years ago, because this kind of thing tends to sort of snowball. Which takes us to Scala. So their problem is so simple compared to our problem right here. Traits. So traits are essentially our mechanism for multiple inheritance. Protected, the very idea of protected is that you have something that your subclasses can access. But of course, Java being completely designed around single inheritance, protected is very much slotted for a linear path. Now we also have protected, but you can have an arbitrary number of parents, and you need to be able to access their protected stuff. From the point of view of the virtual machine, those aren't your parents. Those are just other classes. What are you doing? So of course that stuff all has to become public. And it's got to get mangled so it doesn't start colliding with each other, because you could have 5 parents, each with a private method with the same name. And if you're going to be calling all those things, or if those things are all going to appear in your class, they can't just go colliding into each other. So the mangling starts happening. What's this? Take a look at what we've started with. In the trait, there's a private val which is never touched. This is what the bytecode that we generate for Q1. So those monstrosities are the consequence of how the trait encoding is done. So there's another thing we try to keep working here, and that's separate compilation, which makes everything like far more difficult than it would otherwise be. So you want to be able to compile trait P1 all by itself, and then go and compile class Q1 all by itself and get something that works. Well, in order to do that, this is where we end up. Those methods are, if you take a look at the second one, right, because there's a setter. See, X still has to be populated when the thing is created. And the only way that we can create it and then populate it is to create Q1. So when Q1 is created, it goes down all of its trait parents and calls a method, the trait constructor, and passes itself in. And then it can do whatever it wants in there, and then it gives it back. And that's what happens here. But there's a terrible consequence of this. Do we know what the terrible consequence of these methods is beyond the obvious that they're just these hideous methods? It's what we like takes all our time basically now. And that is binary compatibility. So there's no escape from anything that's in your public interface. So now, like, look at how these terrible things have managed to like compound we have these useless methods doing nothing, which are not content to merely be useless and do nothing. They've ruined the binary compatibility of it. So now, if I recompile Q, if I recompile P, sorry, with a different name for the val, the private val, which Nesha never uses, I'm going to recompile just P1 and leave Q1 alone. We're imagining it to be in a different class, a different file here. And that's the result. So this is like, this is the final blow. You have to step back and say, stop. And this is like the really easy to understand, like distilled version. There's a bunch of variations of this that all have to do with essentially just trying to navigate the JVM. I'm sorry, was there a question? Yes.
Maybe a silly question, but I'm trying to figure out whether the goal here is simply to make this stuff safe at compile time, or whether you're trying to get as close to safe as you can at runtime. I'm sort of thinking by analogy with the Java throwable hierarchy, which is just a fiction of the compiler, and at runtime, you're not even trying to maintain that fiction. Sort of the distinction between between checked exceptions and unchecked exceptions and so on, and I'm wondering whether there's an analogy here. Sort of, if you're only trying to make this work as a compile time fiction, does it get a whole lot easier?
No, we're pinned here. All of this is driven, now I do not suggest that this is the optimal encoding, that there are not other ways to approach it, but this is driven by imposed constraints. And let's see, what are the imposed constraints that force us to do it this way? Right, exactly, because the JVM is extremely unforgiving about whether or not you've actually implemented some particular interface. So in order to interoperate with the Java world, so when you declare that trait, when we compile that, what we actually get are two class files. We get a pure interface called P1, and we get another thing called P1 $class, which holds the implementations of everything in there. Q1 needs to implement the interface P1. Now, this particular version of it doesn't actually have anything interesting in it, but it turns out that it does, because it has to have those methods so that it can be initialized in the general sense. Otherwise, there's no way to do it. There's no way to have any kind of privacy at all. I'm sorry?
The methods are public at runtime. My guess is the mandate.
Those methods are public, right? But the var itself is private. So those methods are public, but they are they are in principle only called during the initialization of this thing. But the var, the underlying var, because Scala will only create private vars. Fields themselves are never directly accessible. They're only accessible through getters and setters.
But say Java code compiled against Q1, Java code compiled against Q1 could go ahead and call the method.
Yes, there's absolutely nothing stopping you from calling these methods. That's correct. It's a strange game we play. Again, it's like if I go back in time, there would be a lot less effort spent on access. Yes?
Just a quickie, but in this case, couldn't it be optimized away?
Well,
Because can anything get to it?
this is why it's but that's the thing, is separate compilation. Things can get to it though, right? Other P1s, right? I mean, it's.
But if P1 has no code, or is that just sort of a minimized example?
Well, yeah, this is perhaps an overly minimized example. Like intuitively there are situations where you think you can get rid of it that you can't, but regardless, I can complicate this slightly,
sure. Okay.
and then you won't be able to get rid of it. But it really is a trick when you need to do something at initialization. Like, yeah, the fact that it's never touched here. We could have, let's say we had just a method in there that just returns a constant y, then our problem is back.
Sorry, a couple of questions. First of all, if you do change x to y, you changed the interface, and so that would imply recompilation of all of the dependent classes.
Well, if you're, I mean, in your good scenario, everything is recompiled. Yeah, absolutely. But that's the thing about binary compatibility. In this case, the Q1 is some person out there in the wild who is working with the original version of P1.
Yeah, but the interface has been changed, and so, you know, even in Java, if you do this will not work.
Oh, absolutely. But in Java, the change is not inflicted upon you here. It's like you didn't set out to change that interface. That's a private val. In your mind, that's a private val. You can change a private val in Java without the interface changing.
So second question is, why didn't you have a single setter for all of the fields in the trait?
Well, there is, in the sense that there is only an init method.
Well, you have a setter for P1, you know, val y equals 1, and another one for another val.
That is true.
One for all of them with the standard name.
Well, and I should preface this with saying, like, I don't have these things, right? It's like, I just work here. No, in all seriousness, though, there's very little that I can actually, like, for good or ill, that I can claim as my original design. I spend my time reverse engineering things. So I would have to look, and I would be happy to do that. I think we're going to have plenty of time. I want to look and see actually what is generated with multiple vals. But it is likely, though, that because this scenario is kind of obscure, it is sort of optimized for the more general case, which is to say not optimized, but it's written for maximum generality. That would be the general reason why there's not like obvious common sense things done here, because the really obvious common sense thing here is just not to pass it all over the place in the first place. And that's why this is on my mind, because at some point I started arguing for changing the trait encoding, which has now become of more importance now that we are trying to maintain forward and backward binary compatibility, and it's essentially impossible in the face of stuff like this. You've got to be able to have private data that does not, you know, like pervert your entire effort every time that you touch something. Are there more questions before I continue? I have lots more. I'm a little weird, and that always makes me laugh. I've known Brian forever, since like the 90s. And just by complete coincidence, here we are, standing like a vast distance from where we met each other, doing similar things. But it's so apt when you get to the next slide. And the real comedy of it, those are the bridge methods just on some randomly chosen collection class. But the real comedy of it is it's not enough. We have bugs that are a direct consequence of not generating enough bridges. In fact, there's at least three distinct categories of bridges that we do not generate either at all or enough that I can directly pin on errors of this kind, linkage errors. But at some point, it's too expensive to generate every imaginable bridge. But going back, in case it didn't quite sink in what the idea there was, this should be the VM's job. It's ridiculous that I'm trying to like pre-analyze the entire universe of possible variations on these methods. The VM has all the necessary information to do this. It's trivial on their end. For us, it's a constant source of bugs, and like bad bugs too. These are like the type bugs where you're just looking around at the shattered bodies. It's like this is a no-brainer. They should just go back to 2004 and make it a VM thing. As I said, it always makes me laugh. All right, specialized. So, among the good ideas that somebody had at some point for not putting things in and out of boxes all the time was, what if, when we have a generic situation like a type parameter A, what if instead of like always putting it in a box and sending it off to the A and doing its boxy thing and coming back out, what if we said, this A is, we know that this A is going to be an int like a lot of the time. Let's take all the methods that it would call and make different versions of them that are specific to int so that we can just give it an int and get back an int and everything will be peachy. That's specialization. This is specialization. This is what happens. Without that specialized there, you get two class files out of this. You get s1.class, that's the pure interface, and you get s1$class.class, that's what we call the implementation class, and that contains the body of f, so x. And then you go from 2 to 20 as soon as you put the specialized in there, because there are 9 primitives if we include unit, and so you get 1 for each, which was, in hindsight, big mistake. We could have done specialization with probably 3 types instead of 9, and then some of the next slides wouldn't look quite so ridiculous, because everything smaller than int could be funneled through int, and long and double could both go through long, so you really just need a 64-bit path and a 32-bit path. You just do bit twiddling on between long and double and between int and everything else. And you don't need unit at all. But hindsight being 2020, that's what it looks like. So that gives you a sense of what's happening with specialization. We're not content with just F that takes an A. We want an F $MCZ $SP so that when we come along here with a Boolean, we've got a really fast, already ready for us method that takes a Boolean and we're off to the races. Specialization works really well when you stop right here and that's all that you do. If you take one method and it doesn't have any inheritance going on or any interaction with anything else, and you're just going to do a thing, you're essentially just using it as like a boilerplate generator for these 10 methods, works great. That's about the end of where it works great, unfortunately. Now this is a little look at what each of those interfaces looks like. Let's make sure that we've got the whole flavor. Now we get to the land of the exponent. So if one type parameter gives us 10 times as many classes, then 2 type parameters must give us 100 times as many classes, and so on. So in this contrived and yet not contrived scenario, we can get a fairly good multiplier effect on our 118 bytes of source. I think anybody would call that a victory. 5 megabytes of byte code. If I was willing to wait the compiler out, I could have thrown a 5th one in there. You start waiting a while. But I guess it should multiply nicely by another 10 approximately. But that gives you a sense of the problem too. Even if you don't have this situation, you have a giant multiplier in your face, and you have to make all these hard decisions all the time. And you don't want to. You don't want to like decide in advance that the important things for this method to be called with and be fast are int, Boolean, and short. I mean, it's just not like, this is not how we want to spend our time. Computers have gotten smart. Let's let them be smart. And we think about like high-level abstractions, not about like micromanaging the plumbing. So this is something that, a relic of a bygone era. Unfortunately, it's actually, I did rip it out as an experiment, and admit it's too good, right? It's too fast, right? Because the few things that we have specialized are so much noticeably slower if I rip out specialization that until I figure something else out, we're still stuck with those. So here's the list of the abbreviated list of knocks on specialization. Yes?
So it seems that specialization gives you a lot of classes gives you more code size. Presumably that means longer compile time and longer load times.
Oh yeah, well you can certainly measure with your stopwatch the longer compile time if you're heavily specialized.
Are there any other negatives besides those two when you've got bazillions of classes? For example, if you wrote some code that had bazillions of closures, you would also get an explosion of classes, although not multiplying this way necessarily.
Yeah, it's hard to get the specialization level multiplier with any other angle, but specialization can sneak up on you. So for instance, when we specialized function 1 and function 2, there was a not quite appreciated side effect of that until after, which is that there are other methods on function 1 besides apply. There are two, like, essentially convenience methods. There's and then, and there's compose. So these are trait methods, but because they reference the specialized type parameter, they led to, and because they had in their bodies, they have like a closure. That closure was multiplied out. So we ended up with like 300 new class files that were just and thens and composes. And so this was like a really bad deal. Like these are these like fringe methods. You don't even really care particularly if they're specialized. It's not that big a deal. Definitely not to the tune of, you know, a megabyte of bytecode or something. So I had to roll out a no specialize annotation just for those, just to suppress specialization under those conditions so that we didn't have to eat that. So yes, there's that. But the biggest reason not to use specialization is that it is buggy in painful ways, and that you will never figure out if it strikes you. So you have to be willing to say up front, I'm never going to want to like do something more complicated than this thing. Otherwise, your life will be working out specialization issues. And between that and the stuff we haven't, we don't even have like all the major stuff implemented, right? Or it doesn't work with arrays. Like this is dropping the ball right here, right? I mean, arrays, that's where like all your fast number stuff is. And so we have this mechanism manifests, now class tags, for passing the necessary information to a method so that it can create arrays. But specialization is ignorant of that mechanism. So you have these two like extremely, like should be working together in lockstep mechanisms that are quite the opposite. They don't even know about one another. So this is just like where you do the postmortem and then you tackle it again. My ambition is to take specialization out just because of the amount of time. It's such a time sink. It's just everywhere, just touching everything and making everything complicated and hard to understand. So the trick is like we need Java 7 and maybe we need Java 8, I don't know. But we need method handles to have a plausible alternative for specialization. So for now, I just say a little prayer each night and go on to the next day. This is the kind of weird stuff that's what I was talking about that I come up with on the train here. I don't know why I think this is so funny, but maybe you guys are all too young. I don't know. If you're approximately my age, you remember Transformers. Megatron was like the bad guy. Anyway, megamorphic is what happens when a closure call site, it's like where you see too many different types there, so you lose your optimization, it has to de-optimize. And Optimus Prime was the name of the main guy. Anyway, you just got to trust me, this is really funny. And then I have one more slide, which is an improvement on this, no question. And then that's the end of my actual written down slides, but I'm a pretty good live coder, so if anybody wants to see anything live, I'm more than happy to take a swing at it and or answer indefinite numbers of questions. If you follow all the Scala lists, which I hope none of you do, you might have seen this a month ago, but yeah. Question?
So did you get hit by the 64K limit?
Only with Adrian's code. The pattern matcher does have a tendency to hit. It's the pattern matcher where that pathology emerges. And in the case of the pattern matcher, it's because we have a whole new pattern matcher, which was a lifesaver, but it has not been battle tested in the face of, especially people will generate code with 500 cases doing some alternative things, stuff no human would write, but that's really good at inducing that. Under normal conditions, absolutely no. Normal code written by humans should not hit the 64K limit. But why? Is that something you encounter? I mean,
yes.
With pattern matching? Yeah.
Which version?
And do you mean with the 2.9 matcher or the 2.10 matcher?
I'm not. It's not in the Scala environment. So.
Oh, all right. Yeah, right. So if you're hitting it in an environment where it's not induced by the high levelness of the language, but by inherent stuff, then you're bummed. You just got to break it up, because yeah.
So it's actually not only pattern matching, that is a classic case, but if you've got any kind of generated code, you know, like LAR, parser generators.
Yeah, it's like when you have an NFA or something, and
Right,
yeah, you just get this state explosion, and in general, it's like the natural thing to do is just let it explode, and yeah, 64K is just not enough to do that, so.
What we actually ended up doing was augmenting ASM to do splitting of code.
And yeah, people should do a lot more of that. I mean, you can do an enormous amount with bytecode rewriting, and you know, depending on the situation, I would definitely consider that route. We're now shipping ASM with the compiler, like we've moved to ASM as the backend, which was a great step forward rather than the homebrew one, because it lets us re-sync up with like the rest of the JVM community. So I'm excited about the prospects for what we'll be doing with ASM before too long. But just using it for our regular stuff is big progress. I saw a hand over here.
From the
somewhere.
JVM, you get lots of benefits like free GC, free JIT, lots of interoperability, but you get lots of problems as well. Do you ever wish that you could have done it differently and just generated native code?
Well, we got the LLVM project. I don't know. It's like, I'm not a guy who thinks that the grass over there on the other side is probably really much greener. In this case, I'm pretty sure it's not greener. Like the JVM is, you know, like from one angle, it's kind of a comical series of like accidental things being like enormously annoying. But every time I look at anything else with any sort of critical eye, I'm glad of where I am. So if I had to pick, I would go this way again. But I do hope that some of the baggage can be cast off. And you know, things look promising, I guess. You know, the right guys are saying the right things. They seem to be empowered, so I'm optimistic. Which guys? Well, John Rose is, you know, like one of these superhumans, like carries the weight on his shoulders. But I mean, like John is, you know, very passionate about like making this stuff better, right? It's like he's the very large part of the reason why we have invoked dynamic now, and that hasn't played out in Java 7 as like with the kind of impact people might have hoped. But it's just a really long process when you're up against as many things as they are. I think it'll be a different ballgame in Java 8, which is great. So yeah, and you don't need that many guys. It's just great because Sun was AWOL for a long time, and if there was ever a time when like I was sketchy about it, it was when, you know, what's going on, man? But you know, now we're back on like the train is running on time, and you know, time-based releases, and we're doing that too. We're actually doing a lot of kind of sort of little parallel universe. They're modularizing, we're modularizing. Which is great because that means, you know, we're going to get to reuse a lot more stuff, right? Like we need to be much less monolithic. They need to be much less monolithic. But I think we're all on the same page. And there is just an awful lot of, you know, awesome technology baked into the JVM.
It seems like the sort of holy grail isn't LLVM or the JVM, it's like a forked JVM. Because there's some of these things that's just like, that's probably a few hundred lines of code to fix.
Yeah, it's true. And I often wish I could come up with just like 2 more hours a day to be digging into Hotspot. But this is among the thing, if you look at like the long list of, you know, like JSRs and this or that state of things, some of them are very much after exactly that. Now, usually it's sort of oriented more toward like the embedded system situation, but that's, you know, that's not you can have that as your motivation and then you still get to use it elsewhere too. So the stripping of the unnecessaries and down to the core is like, yes, you're right. It would be, and you know where we're seeing that is on the iPhone because of Avian, where this guy basically like re-implemented the JVM from scratch for bundling with apps to iPhone, and apparently it works. They say they're running Scala on it. So I had a little trouble building it, but I totally believed, like I looked at it and the thing's solid, right? I mean, once in a while somebody rolls out and shows you that like this is what happens when you do not have to like worry about 9,000 existing constraints. You just say, hey, let me just do this. Take a look. It's called Avian. It's on GitHub. And yeah, like a couple more people throw in some weight behind that. It could be very, very interesting. I would love to be a like meaningfully on multiple backends. And it's never been really like plausible for that to be meaningful because nothing else is really competitive in 90% of the environments in which we're used with Hotspot. So, we ostensibly run on, a J9, and we had a .NET backend for a while, and, there's any number of other things where it's like sort of, but it's, I would like to really have a meaningful second backend. That would be great. Oh, there's, the mic is right behind you, I think.
Oh, sure. So was any of this stuff substantially better on .NET, like boxing and unboxing, for instance? Or?
I'm skeptical that anything could have been substantially better on .NET just by virtue of allocated hours of labor. It's possible that some of these things stood the potential to be substantially better on .NET. But we never had the kind of manpower behind the .NET backend that would have made that a realizable goal. .NET, I don't know an enormous amount about it, but I know that they had, generics at runtime, which must have just been a whole ball of worms. I'm not sure that I would envy that. And beyond that, I know they've got a lot of stuff, but I don't know how it really plays out in the context of Scala. And now I don't know if we're going to find out because without funding for the .NET backend, it was just the interest just isn't there, right? It's like something that's like it's always on life support, and now it's not even on life support. We pulled it from the repository.
So this one's maybe on the more. I'm not entirely sure if this affects you or not, but the fact that class names are strings in class files.
So, yeah, you mean the fact that they're duplicated about 1 billion times?
Well, that's part of it, but the other part is it's completely non-relocatable. You can't, for example, have a generic interface for end function.
Yeah, not without bytecode rewriting. Yeah. Well, sure, these sorts of inadequacies of the class file format they only strike when you, on those blue sky days, when you take a step back and go, what could we do if we just didn't have something but you're so used to these things being the constraints under which you operate. I mean, that really is, that's like reality to us, right? I mean, there's only so far you can pull back to imagine a different world. Class file format 49 or whatever it is, that's been life for 10 years. So yeah, it would be really neat for that to be at a slightly higher level of abstraction, really neat. But I would not anticipate that without a new VM. It's, but it's the kind of thing that you could do with a new VM, right? You do all kinds of cool stuff. I don't know if any of you have ever seen Maxine, but they had implementation of the JVM in Java. So that makes for very interesting experimentation with the VM when it's written in Java. There's a bunch of neat little tools associated with that too. I don't know if they're still actually doing development on that, but I hope they are because I think it's got interesting potential. Maxine?
I'm on the Maxine project as an intern, and it's still being developed.
Great.
So Maxine 2.0.
Oh, great, excellent. I'm happy to hear it. I use the bytecode verifier there to find some stuff I couldn't find any other way. There's a little standalone bytecode verifier that with it. It's got a nice little pretty output that shows you because the verify errors that the JVM throws are comic. They're maliciously bad. It's something happened. And it's actually possible to enumerate what happened, and it's really malicious. I mean, it's they don't want you to know. If you're going to be generating linkage errors, I don't want you in my house. I'm trying to look all so people can raise their hands, but don't feel any pressure. I really can code something if there's anything, it can be about anything, if it's, as long as it's Scala. I don't know anything else, but I'm more than happy. If you have any questions about Scala at all, they don't have to be about this precise thing. Please feel free to ask. Yes?
What about tail recursion? They said that they were going to work for functional.
Yeah, so tail recursion, that's one of these things where we're totally at the mercy of the VM for the good part, which is, because it's really frustrating because it's first of all, it's only of interest, it's only of direct interest to a small percentage of people. Only that many know that it's of interest to them, right? I mean, there's like a large quantity of programmers to whom it should be of interest, but it isn't. And so it always seems like this, like a border case. It's actually really like quite crippling to not be able to count on it. And so it's the worst kind of bug too, right? It's like as long as there's fewer than 5,000 things to this method, it'll work, and then at 5,001, it'll break. Well, who wants to be like sowing the seeds of that kind of bug all the time? And so we can actually we transform during compilation what we can, but it's quite restrictive because Hotspot's able to do all kinds of stuff and pretend things are final, and then when it turns out they're not final, somebody comes in and subclasses it and overrides it, then it's like switch point hits and it flushes all that stuff, and it does it differently. We can't do that at compile time, right? So we have to assume that anything that's not final might be overridden, and then we can't do the tail call optimization, which means that we're shut out of all kinds of stuff, plus we can't do mutually recursive. But my understanding is that it's never going to happen, and because of the security model, depends on stack walking, right? And so like there's no, maybe they'll come up, people have like come up with stuff, but I don't know, it just looks like it's too hairy and nobody's going to want to really like stick their neck out on something that fundamental and say like, no, it's no problem. Especially now, right? Yeah, especially now, right, especially now. The whole feel to me is like we should just get used to it. It's not happening. So it's trampolines for the rest of our lives.
I don't remember the exact compiler flags. You can set something to 1.6 or 1.7. It does something. What does that really do, and is there a benefit?
Okay, so there is a target 1.6 and 1.7. That is very recent, though. It came with so we used to have a backend, something called FJBG, and that was the fast Java bytecode generator, and that was the homegrown like ASM. So we were generating all our own bytecode, and the weight of opinion eventually got to the point that we wanted the ASM to use ASM like everybody else does. And so the ASM backend started rolling out. Miguel did most of the work on that, and he rolled some stuff in there that was only available via ASM. And that's what would be in the .17 backend, if that is in fact anything. To say target 1.6 would only like basically make it use the ASM backend instead of the FJBG backend. But the FJBG backend is gone, so now I don't know if target 1.6 does anything. Do you? Right, so target 1.6 means that you can use bytecode version 51 instead of 49, which means it like pre-generates like a bunch of analysis, which takes some of the weight off the type checker, the JVM type checker that does like the verifier that makes sure that like the right type is in the right slot. So essentially you get performance out of that, but you also knock yourself out of being able to run on Java 5 because your bytecode is past it. But if you don't care, then that should be strictly a benefit.
So is 1.7 going to give you a setting, going to give you any better code?
1.7 does not have a different bytecode format than 1.6 except for invoke dynamic. It's not going to, at this moment, it's definitely not going to give you anything better in the Scala compiler. If you wanted to, like, sometime in the future, get whatever sort of 1.7 specific stuff is going to turn up, then you could set yourself up for that now, but it might well be a no-op. I'd have to look.
Okay, I'll think of it as a no-op.
That might be best to do only provisionally. It's possible that it's not a no-op, but it's,
I've got one more. So it's only tangentially a compiler question, I guess, but what's the sort of real truth of the reason that there's no type inference for explicit returns? It seems like the easiest thing in the world.
No good reason we'll do it.
Is it just spite?
I can't speak for anybody else. There's no good reason.
Okay.
We'll do it. It's certainly on the list of like any annoyance you have with Scala, I've experienced 1,000-fold. So, and I'm not spiteful toward myself. So, Well, it is. But it's hard because of accidental complexity, not because of inherent complexity. Like a lot of things from outside the compiler, any rational programmer would say, why is that hard? Come and try and do it. Then you'll see why it's hard. So that's because I have tried to do it before. I don't think it's I threw a couple hours at it. I don't think it's rocket science. I know it's not. There's no fundamental obstacle. We will do it. Well, I will personally do it even if I can't get it in there. But I just haven't done it yet. Yeah, it might be one of those. I have a lot of there's a lot of bodies behind me. It's like I don't get everything I want in there by any stretch. But anyway, no reason we can't do it.
Are there Scala features that are upcoming that depend on sort of recent or maybe about to be added features of the VM?
Well, specialization, like we're discussing a method handle, must be some kind of method handle based specialization replacement, but that's very much in the junior days, so that's hypothetical at this point. There's nothing like, the next version is not really about features, and the features that it is about are really more like Scala things like macros than they are JVM things. There's an internal debate going on now, and will continue for a while, I imagine, about what to do about wanting to use Java 7 features, because we're at one of those difficult points. There's God knows how many Java 6 installations out there, and there will be indefinitely. So we're faced with a series of bad options. Try to support 6 and 7 simultaneously with our incredibly limited resources. Don't use 7 features at all, or abandon 6. None of these is appealing. But there's really no fourth option. So we'll just argue about it, I guess. As soon as it's convincing, like really convincing that 7 has things that will make a real difference, then I think that we would be willing to move. But I'm personally like hanging on to 6 as long as I can. I hung on to 5 as long as I can too. I've seen too much how much there is out there, and for like 5 years, all you could get was 6. It was a long time. It's huge numbers of installations. I would like to keep those things, in the middle of our site for as long as we can. Even those sons like, or Oracle, oh yeah, we EOL'd. EOL is misused like beta is with Google. I mean, it's like, yeah, we EOL'd it, right? But it's, when there's 60 million JVMs out there, they don't just die because you EOL'd them, right? They have lives of their own. They're evolving. Yeah.
Getting back to your earlier comments about access, there's private this, protected this, private qualifier, protected qualifier, and they're pretty much the same, and they're broken, and the spec is vague. I've read your comments on the bugs, so I know your position. But is there any way forward on this? How much of this is really caused by the JVM? How much is it caused by fuzzy thinking by Scala compiler people? And how much of it is just history?
Well, there is a certain quantity of resistance to change, especially the kind of, people don't want to break code, which I understand. But when the whole model is inherently broken, and we all have to keep writing broken code because there's nothing else to do because the model is broken, then I think it's time to figure out a way to break as little code as possible, but somehow extract yourself. We cannot implement the semantics that are imagined in the Scala specification to the extent that they are specified.
Well, that's not
cannot implement, right? But to the extent that they are specified, that one can infer what is meant, it's impossible to implement them. And that's not a good situation. I personally feel that when you know a situation like that and you can identify it, then you should go and you should put it out of its misery as quickly as possible. But other opinions also exist. So yeah, I don't have a good answer for that. It's us, it's them, and it's also each new thing brings a whole new dimension of why it's impossible. It's.
Just a follow-up to that, if access control doesn't work, if it's too complicated, can you, with your knowledge of how hard it is and where the problems come up, sort of suggest a safe subset? of access?
Yeah, I can certainly tell you like what the most broken things are. So you don't want to combine protected with any sort of anything, basically. You don't want to use protected at all if you can help it. You don't want to use protected, because the problem is that protected is where most of the difficulty lies, because protected has a very specific subclass-oriented meaning on the JVM. But protected in Scala almost never means that, because nobody writes these linear series of class hierarchies. They got a bunch of traits and whatnot, and they mix them up. Furthermore, when you write something like protected package, then like the wheels really start to come off here. And then when you have like nested classes and you're like protected nesting guy, and you've got, if you ever look at like what the protected accessors look like and the super accessors, you would be put off of using this stuff in a hurry. So yeah, the long and the short of it is try not to have any kind of private data and traits if you can help it. Traits should, like, to the extent possible, be like extremely transparent, non-side effecty encapsulations of behavior, but not of state. And then in classes, you can have private this, you can feel reasonably good about it that it's going to act just like it does in Java. If you're in a declared class, in a directly declared class, the private should act like private's supposed to act. And then I would avoid as much as possible, like as much as possible, everything would be public. But it's really annoying because of the conflict between, it's binary, like there's this tension, this huge tension. It's not like one of these, like there's a light tension. There's a gigantic, like, no, there can be only one winner sort of tension between binary compatibility and like optimizability. For instance, like the inliner, we want to be able to inline stuff. It's got to be public in order to be able to, like, if you've got some piece of code that would benefit tremendously from inlining, you can't do it if it's accessing a private thing over here. Well, wait, but I don't want to make it public and turn the binary compatibility situation over here. That's not part of the interface, but there's no other way to do it. These are frustrating, right? It's like I'll work really hard to like find a way through the forest of spikes and like knives and flames, but it's when there's no win, when you cannot win. There's like the giant 100-foot chasm. That's not so fun. So yeah, that's one of those things. So I avoid qualifiers, avoid private this in almost every circumstance unless you know exactly what the deal is, because there's a whole bunch of bugs that like are looming there. But there are places where you do want to use private this, because the big thing you get out of private this is that it does not generate the accessor and it accesses the field directly, and sometimes that matters. But that also is why it's like subject to a bunch of bugs.
The other thing that I encounter a lot is with Java code is you want to emulate Java protected. And it's not very clear from the docs what the Scala version of that is.
Yeah, the Scala, well, right. So you mean like Java unstated, like Java package protected? Because Java package protected, right. So in principle, the equivalent of Java package protected is, because protected includes package, right? I can never like keep Java access straight, right? If your protected includes package? Yes. Yeah, okay. So that means the equivalent of just package is private package name. So if you're in package foo, private foo means the same as Java's I didn't say anything, Java's invisible qualifier, right? Protected foo means the same as Java's protected, because it includes the package automatically. When you say protected foo, it's additive. That means it's protected, all subclasses can access this, and everything in foo can access this.
That would be a great statement for the docs. It's additive. That's the single phrase that...
You're absolutely right. I'm sorry if it's not in the docs. I've put that in a comment at some point, though, for what it's worth. I had to reverse engineer all this myself, so it's hard for me to understand. It should be hard for you to understand. I don't actually think that, but sometimes it just kind of works out that way. And also, I resist documenting things that I think are wrong and the wrong way to do it. It's like I feel like an enabler at that point. I feel like it's the least that I can do is at least throw my inertia at not helping this thing become even more entrenched.
Okay, so you mentioned that there was like problems with like binary compatibility, but also with like trying to make things public versus like protected and so on. So has there been any other thoughts like perhaps having an annotation that says like this is intended to be internal, so it doesn't like show up in code when you're looking through it, like the Eclipse plugin, but that would give you the ability to basically skirt it and say that this is like accessing the Sun classes. If you access these, we don't guarantee that they'll work in the future.
It's so there is like we can recapture an element of the problem that way, but we are really haunted by things that are not negotiable, which is to say the JVM, and this is one, these are the things that we can hope for in the future to change, but they're the way they are right now, is there's no room for error on like an interface implementation. And so if it's not exactly, what it expects, then it's gonna throw a linkage error. And so, in terms of like what we're gonna guarantee for binary compatibility, we should definitely like, to the extent we can mitigate some of this stuff by saying like, okay, this is public, but we don't really mean it. And this has been discussed, but it doesn't really save us from the problem that like we need to change the name of a public thing in an interface and things already rely on that. There's no way to not make that break things.
Or perhaps you could take the Java or the Java approach, or like what you had before, where like if it has a $sign, then there's no way to actually reference it as well. So that way that you can prevent people from actually binding to those classes because it's using a symbol that is not actually valid in the language.
Right. So to the extent that we can, and in fact, such things are excluded from binary compatibility considerations because there is a set of things that you can accomplish. For instance, like you can add a method to something and retain binary compatibility if there's nothing that's ever going to call the method except for your own thing, right? So these scenarios arise and we get them, but it's like, again, if you go look at the trade encoding situation and there's, sometimes you just can't do anything. Your hands are tied. There's an interface out there. Things are extending it. There's clients in the wild, classes, they have those little bits all in there, and there's just no way that you can fix it without breaking it or without them recompiling. I don't know how long this thing goes, but I'll be here until they say I should go home. So so that people don't feel like too much pressure to ask questions. I'm just whatever you ask me anything. It's like AMA. I'm a Scala programmer. Ask me anything. So I could use some water, and you guys look like you have nothing left to ask at this second. But yes, is that a question?
Yeah, this is not directly related to the compiler, but like, would it be possible to have an interface to the REPL? Like the people at AmpLab, like every time they...
You don't know how much I poured into the REPL that you've never seen. Like months of my life. The stuff I've done in the REPL years ago, at the JVM Languages Summit, which is here on this campus, thank you very much, which is here on this campus every year, like 3 years ago, my big thing was this multi-language REPL. It was so cool. I was running Ruby closure in Scala, and I was able to like call map from one thing to another thing, right? So I was like funneling the data through the implementation. I had all the implementations linked, so you could sit there in the Scala REPL and then just say like, hey Ruby, and you'd take your list from Scala and you'd call like map on a Ruby function and get back the stuff. In the process of doing that, I did a great deal of like interfaceification and just like I had a whole scenario. The answer to your question is I've done so much work on that, and then it's just like a lot of work that I've done, a tremendous amount. It languishes in a sort of limbonic state, waiting either for me to get back to it or for somebody to come along and say, I got to finish that. That's why I bring it up, because that's one of like the best things I never published, and I'm really sorry about it. So yes.
No, the reason why is like every time they try to do a new release, they have to fork it.
It's terrible. It's terrible, and the worst thing is I resist making even little incremental improvements because now they feel so insufficient to me. Because right, so this is terrible. The perfect is definitely the enemy of the good here. Like the perfect is like putting the good out of its misery. So I sympathize completely, but I have to overcome my like internal issues here with the subject. One of these days, though, a switch will flip and you'll just see this whole new. Actually, well, we're kind of heading that way because in the course of modularizing things, as we are presently doing, once the REPL gets broken off like it ought to be, then it will just be much more like sort of a natural path toward me making incremental improvements. But we have to demonolithize the repository, and that's really my priority right now. It's a long time to talk. Yeah. Anyway. Yes.
Go ahead and drink while I ask the next. Is there anything about Scala 210's macros that required some extra feature of the JVM that wasn't used much before? Or is this all bog standard stuff? It couldn't be. Just accessing the AST, exposing the AST from the compiler? Is that what really the whole thing is?
As time goes on, I have no doubt we'll dream up ways that the JVM could be more, helpful. But macros are almost exclusively a Scala problem. It's a problem of just taming the complexity of the compiler more than it is anything inflicted on us by the JVM. I'm sorry?
How many lines of code in the compiler?
I don't know, 250,000, something like that? No, 200? Well, it depends. What are we counting? No, it depends on what we're counting. That you shouldn't count the library, but on the other hand, the collections are, it's not like it would run without them. I would have to count, but certainly it's over 100, and probably between 100 and 200. It's a lot. Since I happen to know, because I counted it recently, for some reason I have 5,800 commits, which is a lot. It's, I don't know over how many days. That's over 1,200 days, yeah. So that's 4 or 5 commits a day for, 1,000+ day, long time. Yeah, long time.
So, is there any intention of moving some of the Scala stuff that was done in the past as part of the language and turning them into macros that depend on?
Oh yeah, I got a long list of macro targets. Some of them I've already gotten, and there are more. So XML gone, case classes basically. Any to string add and all of some of these, and I'm more interested in just making these things avoidable than I care about them being macros. Any to string add anyway, but they also are just natural for macros. Class of, which was compiler special case, I implemented as a macro, and also that made me spin off on a whole bunch of stuff, being able to say I was trying to get companion of to do the right thing. Yeah, honestly, it's from an internal standpoint, there are many places where you can see it. It's quite apparent. The special casing that is just once you have the sort of a picture, a macro-y picture of things, it's just suddenly it's a choice between this horrible hacked-in special case and a sort of modularized natural extension. There's no contest. It's really going to eventually simplify the compiler tremendously, which is a relief. Do you have any in mind when you say that? The yes statement? Well, so do you know about the LMS? Yeah. So because, right, I'm all for abstracting over that kind of thing, but it's there's only so much of the Turing tar pit you want to throw people into at once. But I'm not somebody who thinks that there's an obvious stopping point in abstracting over stuff. I want to make the parser. I want to be able to trivially override the parser and have different parsing. I want to have lexically scoped syntax. So I can import from something and have the syntax of that block be completely different, like another language. And Martin doesn't go for that kind of thing, but I think it's great.
The reason I mentioned the Lisp, the if statement, was it was the one thing in Lisp that was actually that could not be implemented as a macro.
Oh, that was the primitive?
That was the primitive. But in terms of in terms of simplifying the language, because I imagine that a large portion of it could not easily, but could be moved over and simplify the entire.
But you really do start walking into the Turing tar pit here because it's attractive from an aesthetic standpoint to start implementing your language in terms of more fundamental pieces of your language. It is also a trap, and if there's not a really tangible benefit to be had, it's probably a trap in the trappy sense of a trap. It's going to make things slower, and then you're going to discover that there were actually distinctions that needed to be maintained that have started slipping away from you as you've built up this beautiful diamond-like jewel that's now slower and does at best the same that it did before. So I totally understand the appeal, but it's one of those things one has to approach with reservations.
Going once? Going twice? Any more questions? Yes, another question.
The slow part? It starts at the beginning. It rolls up to the end. What's the slow part? So there's different ways to answer that question. I can tell you what you're doing to make it slow, because it's your fault. Don't blame the compiler, for God's sake. People don't appreciate, but what I do mean is that you have a lot of control that you probably aren't aware of, or at least very possibly aren't, about how slow it is. And it is just a few things that tend to really dominate. Type inference is, and especially people gratuitously require type inference that is extremely time consuming. And it kind of sneaks up on you, because if you don't have, if your eye is not attuned for where type inference is taking place, then you will be looking at this unholy terror of lubbing and unification, and to you it just looks like list 1, 2, 3, right? Because the problem is that anytime you have a situation where there's an expression without where the type needs to be inferred, and another expression where the type needs to be inferred, and then some other expression that is unifying those types. For instance, this could be as simple as if then else, but it could be a list of things where the type of the list is being inferred from a series of expressions. That's one where you really get these really ugly, because people, in generated code especially, they'll generate 200 element list, and now the types might just be 5 plus 2, but the compiler is throwing on stack frames as fast as it can go, trying to figure out what the lub of this list is. You could have just put the int up there, say list int instead of list, and saved 10 seconds off your compile. A number of things are slow, but that's the easiest to control. I'm on reserve battery power. That's terrifying.
Somebody tweeted that syntactic sugar gives you compiler rot. It was the last couple of days. Syntactic sugar, excessive use.
It's doesn't it give you cancer of the semicolon?
No, compiler rot.
I believe that's the original quote.
You got to see the computer dentist.
All right, I'm gonna since I'm on reserve battery power, I'm gonna terminate this thing. Terminate. Right, that's what I meant by terminate. If I can figure out how, which I cannot. There we go. Stop recording. Use my last 5% in I/O, I assume, and call it a day. All right, there we go. Now we're off the record. Now we can ask the truly controversial questions.
Dun, 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 dun.
All right, it still hasn't saved it yet. Cam. Oh yeah, really. Go SSD. No messing around.
Any more questions for Paul?
You have 8.9 seconds.
So, I don't know that much about macros, but when you're in the situations where you have 22 different versions of a method with 22 different possibilities of type parameters, is that the kind of thing that could be macroed away?
Well, the thing about macros is that you can accomplish a lot on a per call site basis, but you cannot macro away the problem of if you'd like to have a piece of compiled code that is you compile it and now somebody else comes along and wants to work against that code, either if it's fully generic code, then it's going to be slow and boxy, and if it's got specialized paths, then it can be fast. And they're the ones who now need to be running macros, because macros got to have access to the AST, right? So you can use the macros can be a very fancy inliner, right? And so that's essentially, so yes, in a manner of speaking. And one of the things that I did a while ago was like, as an experiment, I eliminated, most of the closure that arise in the course of using the collections. For each map, there's all these. So every time I would just rewrite, every time you try to call for each, instead of actually like allocating closure and passing it to for each, I would just take the body of the method that was in the closure and I would make a local method in the class, and then I would just call it and inline the for each code right there. And so, it's like magic. I mean, you see something like that, you're like, wow. Many things having to do with like type-specific stuff, yes, because if you're at every call site and you can see exactly what's there, then you can do an awful lot of very specific stuff. But there is there are downsides. So it's you have to walk carefully, and especially becoming dependent on macros for too much, because it's another one of these traps. It's very appealing and very powerful, and if you get a little too far down this road, you have this undebuggable situation. It's like it's much harder to figure out what's going on. I hope we can bring more transparency, especially now because macros are freaking impossible to understand. But if we can bring more transparency to the process, we have to give you the tools to be able to use them tastefully. Like implicits, what is it if, violence in XML, if it doesn't solve your problem, you're not using enough of it? That'll probably be true for macros too.
Okay, I think we say thank you at this point.